Okay, this is Math 200. We're looking at Chapter 2. We'll be doing, this video will be covering 2.1. We are using, my name is Mr. Pledgey. This is my TA, C3PO. And we're going to be covering 2.1 that deals with solving linear equations. Okay, so the idea is isolate the variable. Get 1x equals is the name of the game. So if we're given an equation that looks like this, or like this, let's solve those equations. So how do we go about doing that? Well, you want to get 1x equals, isolate the variable. That just means get x all by itself, all right? Or whatever variable they have. So first, we have to clean this one up. They have like terms, but they're not combined. So these are on the same side of the equal sign. So I'm just going to add them up. 6x and negative 5x, that's 1x. And then the plus 8 is still there. Those are unlike terms. This says an x on it. This is a number, so you can't combine those ever. The equals come straight down, and then those are also like terms. It's a number and another number, so we can add those together, or in this case subtract. So 8 minus 3 is 5. And so now we haven't really started working out solving the equation. All we've done is we've simplified it. So we've combined like terms and simplified the equation. And so now the object of the game is get 1x equals. And it becomes kind of a game of opposites. So plus 8, we minus 8 from both sides. And so that ends up as x is equal to negative 3. Now the upside of this is you can always put that back into the original equation to make sure it works. So if I pop a negative 3 in there, that's negative 18 plus 8 is negative 10. And then negative 10 and positive 15 is 5. So that turns out to be 5 when I sub in negative 3, and then that side also turns out to be 5. So 5 equals 5. Let's do another one. Isolate the variable, so we add 1 to both sides. That gives us 3z is equal to 27. And so we've isolated it. We've gotten the variable all by itself. The z is all by itself, but it's not 1z. We want 1. The coefficient, the number in front of the variable, is always called the coefficient. And so we want a 1 there. And so 3 divided by 3 is 1. 1z is equal to 9. Now, in math, we're lazy. We don't usually write 1z. We just write z. If there's nothing in front of the variable, that means there's a 1 there. All right, let's take a look at 3. Is 8 plus z equals negative 8. And 4 is 4p minus 11 minus p is equal to 2 plus 2p is 20. Ooh. So that looks like a big problem, huh? All right, we're doing good here. I'm going to turn off the noisemaker here. All right. And so this, be careful. Lots of students look at that and they go, oh, I don't even have to do any work. It's 0. It's so not 0. If we isolate the variable, we would be subtracting 8 from both sides. And negative 8 and negative 8 is not 0. So this is 0 plus z, or just z. This is negative 16. All right? Let's look at this one. Combine like terms first. It's 3p minus 11. Combine like terms again, that's 2 and negative 20 is negative 18. Get all the variables over to one side. P minus 11 equals negative 18. And 11, P is equal to negative 7. So be very cautious when you're working out equations. You gotta really mind those positives and negatives. All right, so moving along. Page 2. I'm going to up the game a little bit here, and we're going to do the distributive property. So the distributive property is when you have a number in front, usually, of a parentheses, and you multiply it through those parentheses. So look, I'll have 3 times 3x minus 5 equals 10x. We've got 5 times 3 plus z minus 8z plus 9 in parentheses, and then equals negative 4z. All right, so we do the distributive property first. That is 9x minus 15 plus 10x. And now you solve it, just like how you would solve any other equation. So we want to get the variables all over to one side. You don't always have to move the variables to the left side and the numbers to the right side. I could do it either way. And so look, we get negative 15 is equal to 1x, or just x is equal to negative 15. So it doesn't matter if the number is first equals the letter, as long as there's a 1 in front of it, it's by itself. You just rewrite it. Think about it, it's an equal sign. So if I had everybody line up by height, and you were the exact same height as the person right next to you, you could switch spots, because you were equal in height. Same thing's happening here. Negative 15 equals 1x, x is equal to negative 15. Doesn't matter which one we write first or second. All right? Distributive property, 15 plus 5z. Now this negative distributes to both of those. So if you worked ahead in the packet, and you have a plus 9 there, you made a mistake. That negative changes the sign of both things inside of the parentheses. It's like negative 1 times that and negative 1 times that. So now we combine like terms, we get negative 3z. We combine like terms, we get plus 6, negative 4z. Again, we're going to get the z's over to one side. So I add 3z, I get 6 is equal to negative 1z. I don't want negative 1, so I divide both sides by negative 1. Z is equal to negative 6. Now I've had students say, oh, I didn't divide, I multiplied both sides by negative 1. That's fine, that'll still give you the same result. We want to get 1z equals. And so if you divide by negative 1 or multiply by negative 1, you will get 1z. All right, let's look at 7. It's 12x plus 30 plus 8x minus 6 is equal to 10. So we combine like terms, we get 20x. We combine like terms, and plus 24 equals 10. Now officially, I know I did something there, but I didn't really do any steps yet. What I basically did there was I just cleaned it up. I combined like terms. I'm going to now start doing steps. So if I were talking in terms of math, I would say this is a 2-step equation. Even though that took a little bit of work, it doesn't count as a step. This counts as a step because I'm subtracting 24 from both sides of the equal sign. That isolates the variable. And so I've had students ask, well, why didn't you subtract 10 from both sides? Well, then you're moving this number over to this side. We want to get this by itself. So the side with the variable always kind of drives our decisions on what's going on. Now we divide both sides by 20, and then a whole bunch of students throughout my career, 31 years already, automatically think they did it wrong. Oh no, I did it wrong. I didn't get a whole number. I was supposed to get an integer. No, that's not true. We can reduce it, so it wasn't all the way right. We can reduce, divide by 2 top and bottom, and you end up with x is equal to negative 7 tenths. That's fine. That's a fractional answer. Those happen a lot. Unfortunately, in math, us math teachers kind of mess you guys up because we always want it to work out to be a nice, neat, whole number. And so then when you get a fractional answer, you automatically second guess yourself and say, oh, I must have did it wrong. You didn't do it wrong. All right? Keep moving along here. So we're still on 2.1 in the packet. We're on page 2, and we're about halfway down. And so now we're going to work on some more interesting problems where there's some fractions. Oh boy, we love fractions. Got us some fractions here. 3 times y plus 3 divided by 5 is equal to 2y 6, and 3x minus 7 is equal to 3 times quantity x plus 1. Okay, so let's take a look. I got to divide by 5. So there's actually 2 ways to attack this problem. You could say, well, they're dividing by 5, so what I'm going to do is multiply both sides by 5. And then divide by 5, multiply by 5, those cancel each other out. And so we're left with 3 times y plus 3 equals, and we do the distributive property there, 10y plus 30. And now distributed here, 3y plus 9 equals 10y plus 30. And so now we've got all of the sides cleaned up. We're ready to start solving this equation. The other way to do this would be to put this over 1 and then you cross multiply and solve. So you take 5 times that, which we did right there, and then you take 1 times that, which would be right there. And so it's just a different way of thinking about it. All right, so let's, I'm going to red over 10y over. So we get negative 7y plus 9 is equal to 30. And then subtract 9 off of both sides. We get negative 7y is equal to 21. And then divide both sides by negative 7. Now, again, I've had students in the past say, uh-oh, I did it differently, but I still got negative 3. There are a lot of correct ways to do this. If you would have ended up moving the 3y over there, you got 7y, and then the 30 over there, you got negative 21, you still, when you divided, would have ended up with negative 3 for an answer. So there isn't one exact correct way to do each and every step. You can do the steps, or maybe you did them a different order. Maybe you said, I did it this way, but I did minus 9 first and got 21, then I subtracted the 10y and got negative 7. You still would have ended up right here at the same spot. All right? Let's do this one. 3x minus 7 equals 3x plus 3. And then we're going to move the 3x over. Oh, no! We get negative 7 equals 3, but negative 7 does not equal 3. So this is no real solution. No real solutions. And so what that means is when the variables all disappear, when you're trying to get your variables all over to one side, if they all disappear, it's one of 2 scenarios. Either there are no real solutions like this one, or had this worked out to be an identity, meaning it's negative 7, and if that would have been negative 7 equals negative 7, that's true of all numbers, so that it's all real numbers. So when all the variables go away in equation solving, it's always going to be either no real solutions or all infinite solutions. Okay? So let's look. They got 1/6x equals 2/3 plus x over 9. And they've got 3/4 x plus 7/8 equals 7 minus 1/2 x. Okay, and so here, they don't want us to solve these. They just want to know what number could I multiply every term by to eliminate my fractions, to wipe the fractions off the face of the equation here. And so that answer for this one is, what's the smallest number? 6 and 3 and 9 all go into? Well, that would be 18. If I multiply this by 18, and this by 18, and this by 18, what would happen is the denominators would all go away. So 6 goes into 18 3 times, 3 goes into 18 6 times, 9 goes into 18 twice. And so all of those would basically cancel away, and then I'd have a new equation with no fractions. Now, 36 would also work. 24 is out because 9 doesn't go into 24. But 36 would work, but we don't want to use that one if we can help it, because then we're working with slightly bigger numbers, and so you'll still get the correct answer, but you'll be getting there a harder way because you'll have larger coefficients. Okay. Okay. So this one, smallest number that 4 and 8 and 2 all go into, that is 8. Again, if you thought 16 would work. It's a common denominator, but it isn't the lowest common denominator. 8 goes into 8, 4 goes into 8, 2 goes into 8. So 8 is the one we want. All right. Let's get the last page. So this time they actually want us to figure out what denominator clears the fractions. That's called clearing the fractions. And then basically you have an equation with no fractions, so you don't have to worry about finding common denominators to add or subtract. You don't have to worry about multiplying by reciprocals to divide. And so it simplifies the equation. Even if you end up getting a fractional answer, which a lot of times you will. They ask you an ugly fractional question, lots of times the answer is an ugly fractional answer. So let's see, we've got 1/5 y plus 3 equals 7/10. So the LCD, the lowest common denominator, the thing that 10 and 5 and 1 go into, is 10. And so I multiply this by 10, I multiply this by 10, and I multiply this by 10. Now, common error that I've seen over my career is people forget to multiply the 3. They just leave it 3. They're like, I didn't have to fix that. Well, it's an equal sign. So if I multiply the right side of the equation by 10, I have to multiply the whole left side by 10. And by multiplying the whole left side by 10, I do the distributive property, and I end up with a 10 there and a 10 on the 3. So I usually just write it on by each term. It's, I think, easier in my head than doing the distributive property. But if you prefer, you can write the 10 down and throw parentheses on there and do the distributive property. It's fine. All right, so we reduce it. You get 2y plus 30 equals 7. That's 70 over 10. That's just 30 over 1. That's 10 over 5. So I reduce them all, and voila, no fractions. Much easier to work with. So I subtract 30 from both sides. I end up with 2y is equal to negative 23. And then I divide both sides by 2. Remember the name of the game, get 1y equals. So I got 1y equals. And yeah, I got an ugly answer. Negative 23 halves, which is fine. It's an improper fraction. If you'd like, you want to be fancy, you could write it as a mixed number, negative 11.5 or negative 11.5 as a decimal. Now, depending on if we have context to the problem, if it's money, I would want that. If it's bushels of apples or something, I would want that. If it's a slope of a line, I would want that. And so it's dependent on the context of the problem. If they don't give you context, any of these three are fine. I usually go path of least resistance and just leave it improper. Now, don't confuse improper with unreduced. It is reduced. Nothing goes into 23 that also goes into 2, so I can't reduce it any further. Improper just means I left the big number on the top and the little number on the bottom. The numerator is larger than the denominator, and so this is called an improper fraction. This is a mixed number, that's a decimal. They all are exactly the same value. Okay, let's look at 4. Negative 0.2x plus 6 equals 0.35x plus 4.5. And number 5 is 0.4 minus 0.005x equals x. And so this one, they want to know what number would I have to multiply every term by to not have decimals. I don't know about this whole process, because fractions, it makes sense to me to multiply and get rid of the denominators, because fractions add all those steps. You have to find common denominators. You have to multiply by reciprocals. Where decimals, we're a base 10 society. Our money is decimals, 35 cents. Those aren't that hard to work with. I usually don't do this, truth be told. I mean, if you would want to, you can, that's fine. But I don't usually do this. 100 would fix it, because look, this is 2/10, that's 35 hundredths, that's 0.5 is 5/10. So you want to get rid of, like, if I multiply this by 100, and this by 100, and this by 100, and this by 100, then I would end up with a new equation, negative 20x plus 600 equals 35x plus 450. And so here's the trade-off. So I don't have any decimals, but I'm working with larger numbers now. I got 600 in there and 450 in there, and I don't know. It's fine. If you want to do it, that's fine. Look, this one is tenths and tenths, hundredths, thousandths. So we'd have to multiply everything by 1,000, and that would fix it. You'd have 1,000x and negative 5x and 400. Okay. All right. And so then the last one on this page and section is solve this equation. Negative 0.2x plus 53.6 equals x. So if we want to fix this one, so there's no decimals, we would, that's tenths place, that's tenths place. So we'd multiply everything by a 10. And so we end up with this equation, negative 2x plus 536 equals 10x. So we, get the x's over to that side, so minus 2x. And 536 is equal to, not minus 2x, plus 2x, right? Ooh, be careful. Haste makes waste. Negative 2x. To get rid of a negative 2x, I have to add 2x to both sides, so that's going to be a 12x, and then divide out the 12. And I end up with an ugly answer. X is equal to 44.666666666, and then on the end of my calculator it says 7, but it is actually 6 repeating forever. And so we just go 44.6 and put the little line over it. That means 0.6666. The reason your calculator threw a little 7 on there is because it was running out of room. There's no more room, and so it just rounds the last number. So if it's 5 or 6 or 7 or 8 or 9, it bumps it up to the next number. So that's why there was a 7. All right. Okay, the next video I will do is going to be 2.2.